Hello everyone, we are going to discuss the solutions of part 16. So the first question, the dimension of half epsilon naught E naught square is asked. We know that this represents energy density, and energy density has same dimension as radiation pressure. So this whole thing will have same dimension as pressure, which is simply force by area is equal to mlt minus 2 by L2, which gives us ml minus 1 t minus 2. Coming to the second question, SI unit of a physical quantity having displaced dimensional formula mt minus 2 a minus 1. So let's check the first one itself. Tesla is for magnetic field B. To know the dimension of B, we should have a single formula which contains known dimensions like F is equal to QEB, which is the formula for Lorentz force. So from here we can derive the dimension of B as F by QB. Force is simply mlt minus 2 by AT, charge is current into time, into velocity is LT minus 1. So from this we get m a minus 1, L gets cancelled, we'll get t minus 2, which is the asked question. Coming to the third question, a plano-convex lens is silvered at the plane surface. What is the focal length of the lens? So we know that whenever a surface of a lens is polished, the effective focal length is given by f is equal to minus 2 by fl minus 1 by fm. This 2 comes because the light crosses the lens twice, so we add it twice. Here mirror is a plane mirror, so mirror is a plane mirror, which means focal length will be infinity. So simply 1 by f becomes minus 2 by fl, and focal length here is plus 20 centimeter. So what we get is f is equal to minus 10 centimeter is the effective length of this combination. Coming to this question, the combination of logic gates is asked. So let's name this M, let's name it N. So if I start from here, what is it? This is a NAND gate, which means X is simply M N bar. This is a NAND gate again with same inputs. So M is basically A into A whole bar, which is simply A bar. N is also similarly B into B bar, which is simply B bar. So Mn bar is simply A bar, B bar, whole bar, and using De Morgan's theorem we can tell this is simply A plus B, which is OR gate. In this question, the relation between V and U is asked. So we know the relation looks like this: 1 by V plus 1 by U is equal to 1 by F. So obviously this answer is wrong. It is not a linear relation between V and U. And if we just look at some of the coordinates of the graph, we can get our answer very easily. When the object is at 2f, the image is formed at 2f, so there should be a 2f comma 2f point here. So this gives the correct answer, and f comma f is obviously not a point on any graph, so this is wrong. Again, f comma f is not any point. Whenever object is at f, image is formed at infinity. And here we can check also, when f is 0, u is f, v is at infinity. So this comes the correct option just by checking that 2f comma 2f should lie on the graph. Next, in the following figure, the logic gate with two inputs is shown. So let's make the truth table, we'll get the answer easily. So this is A, this is B, and this is the output O, which is given by C here. So I'll just write C. If I look here, A is 1, B is 1, C is also 1. We get 1, 1, 1. Next, A is 0, B is 1, C is 0, 0, 1, 0. Next I get A is 1, B is 0, C is again 0, and A is 0, B is 0, C is 0. So this simply is a truth table of AND gate. Coming to the next question, what are the readings of a meter here? So what we see here is a battery. So basically we will get a direct current. If we look at this PN junction diode, the positive terminal is connected to the negative end of the battery, which means it is reverse biased, so no current will flow through this. So in this upper branch there will be no current, so A1 will simply read 0, and whole of the current will go through the lower branch where the potential is 12 volt, the resistance is total 12 ohm. So the current becomes E by R is equal to 12 by 12, which gives us 1 ampere. Light takes time t1 to travel distance x1 in vacuum and t2 to travel distance x2 in a medium. What is the critical angle? So we know that the critical angle formula is sin IC is equal to rarer medium by n of denser medium. So n rarer is simply vacuum here, and it is denser medium is any given medium. So refractive index is simply velocity of light by velocity of light in that medium, which is rarer medium, and we will get C by velocity in denser medium. So we get velocity in denser medium by velocity in rarer medium. So speed is distance upon time. So in denser medium it travels distance x2 in time t2. In rarer medium it travels distance x1 in time t1. So we get x2 t1 by x1 t2. So IC is equal to sine inverse of x2 t1 by x1 t2. Next question. A Polaroid examines two adjacent plane polarized beams A and B whose planes of polarization are mutually perpendicular. So there is a one beam coming like this, and another beam has plane of polarization exactly perpendicular to this beam. Suppose this is A, this is B. In the first position of the analyzer, beam B shows 0 intensity. So if I want 0 intensity from beam B, the angle between the polarization direction and the axis, polarizer's axis, should be 90 degree. So the beam will not pass through it. So intensity we are getting is 0. From this position, a rotation of 30 degree shows the two beams have same intensity. So if I rotate it by 30 degree, angle between B and the polarizer axis, here the theta is 90. But if I rotate it by 30 degree, it becomes like this. So the angle now becomes 60 degree. So intensity which is coming out for B light will be intensity of B into cos square 60. Earlier it was cos square 90, so it was becoming 0. And because A and B are perpendicular, the intensity of light which is coming out from light A is IA into cos square 30, because the angle between these two will be 30 degree, as the angle between these two is 90 degree. And these two intensities are given to be equal. So we'll say IA cos square 30 is equal to IB cos square 60. So IA by IB is equal to cos square 60 by cos square 30 is equal to 1 by 3. Next, two identical capacitors A and B are charged to same potential V. The charge on the capacitor at time t is equal to CR. So just by looking at the question, we know that CR is basically the time constant. It is equal to tau. They have same potential V, so basically initially they have both charge Q equal to CV. If we look at the first diagram, the positive terminal of the capacitor is connected to positive terminal of PN junction diode, so it is forward biased, so it will simply conduct and the charge will flow and the capacitor will eventually get discharged. This is discharging of capacitor. So in first case the capacitor is discharging, and after one time constant we know that the charge becomes Q0 by E, and initially the charge was CV, so the charge becomes CV by E. In the second case, if we see, the PN junction diode is reverse biased, so it will not even conduct electricity, so the capacitor can never be discharged. Capacitor will retain the charge and the charge will always be CV. Next question. Binding energy per nucleon of deuteron and alpha particle are given as x1 and x2. What is the energy released in the reaction? So we know that whenever energy is released, it comes at the gain in binding energy total of the reaction. So the amount the binding energy is increased will be the amount of the energy which is released. So it is basically binding energy of products minus binding energy of reactants. Binding energy of product, the product is an alpha particle, so binding energy will be, there are 4 nucleons and binding energy per nucleon is given to be x2, so it will be 4x2, minus binding energy of reactants, there are 2 deuterons and both have 2 nucleons and the binding energy per nucleon is x1, so we'll get 4x2 minus 4x1. Next question, binding energy per nucleon curve is given like this. So they are asking which of the process would release energy. So we know that the process which releases energy, implies that binding energy should increase. Let's check A option. Y turns to 2Z. Y, the total binding energy of Y was, binding energy per nucleon is 8.5 and it is 60 number of nucleons. So 60 into 8.5 is the binding energy total, and here we will get 2 into 30 into 5. For Z it is 30 into 5 is the total binding energy, and there are 2 Z's. So we had initial binding energy of 510 and the final binding energy is 300, so binding energy has decreased, so it actually absorbs energy, not releases. If we check option C, W turns to 2Y. If we see W, it is 120 into 7.5. It turns into 2Y. 2Y means 2 into Y is 60 into 8.5. 2 into 60 into 8.5. So it is basically 120 into 7.5, and this is 120 into 8.5, which is clearly larger. So the binding energy has increased, it is more stable, and the stability has increased means the energy was released in the process. So option C is the correct answer. Next, refracting angle of a prism is A. Refractive index of the material is cot A by 2. What is the angle of minimum deviation? So we know that refractive index formula for prism is sine del m plus A by 2 by sine A by 2. It is given to be cot A by 2, which is sine A by 2 by cos A by 2 by sine A by 2. So if we cancel the denominators, we will get sine of del m plus A by 2 is cos A by 2, and I can write cos theta as sine 90 minus theta, so I'll write it as pi by 2 minus A by 2. So pi by 2 minus A by 2. If I compare it, del m plus A becomes equal to pi minus A, implies that del m is equal to pi minus 2A. Next question. This is a YDAC experiment. This is a screen which is moving away from the source continuously. We have been asked the ratio of intensity at point P. So P is a maxima initially, and O is obviously the central maxima. And as we move the screen away from the slits, what will happen to the fringe pattern? What will happen to the intensity at point P? Let's think about this. So as we move the screen away, beta, which is the fringe width, is lambda capital D by small t. And as D is increasing, beta will also increase. So beta increases means the pattern spreads. The pattern will spread out. So initially, this is O, this is P. It is a maxima, it is a maxima. Again, similarly, we have a maxima below also. This is the central maxima. When the pattern spreads, this minima will start shifting towards P. The maxima at P will start shifting upwards. So slowly, the pattern, you will notice that the central maxima has become so wide slowly that the minima reaches P. So the intensity at P drops to 0 from maximum value. But as further it spreads, it will become so wide that P will again have some intensity. It has become so wide that the P again has some intensity. It becomes 0 here now, so it is wider. So the intensity has again increased. So it decreases, then again increases. So just think in terms of the spreading fringe pattern. Next, the pendulum is oscillating in a vertical plane about point O in refractive index mu. The observer is seeing from above. The pendulum is performing small oscillations about the equilibrium position, the equation of trajectory of the bob as seen by the observer. Okay, so let's see. If the bob is like this at depth L and the observer is seeing from here, this bob will appear to be at lesser depth, which is called the apparent depth, and the person is in air. So apparent depth by real depth is given by 1 by mu. So the apparent depth will be L by mu. As the pendulum is oscillating, suppose its depth is something, suppose it's y. So the person will see that the depth is y dash, which is y by mu. But this shift in x will be same, it will not be changed. Suppose this angle is theta, the length is L. So what is y? Y is L cos theta. But apparent depth y dash, apparent position in y direction is L cos theta by mu. X is L sin theta, and apparent position in x direction is also L sin theta. There is no issue in x direction, there is no shift in the x direction. So if we look at the apparent positions, we get an equation of trajectory just by taking y dash into mu by L is equal to cos theta, x dash by L is equal to sin theta, and if we square add, we'll get 1. So we'll get x dash square by L square plus y dash square into mu square by L square is equal to 1, which is an equation of similar to an ellipse. It will move an elliptical path. So this can be written as, this term can be written as y dash square by L by mu whole square to match the options. So the only thing which we have to keep in mind is the apparent depth means the apparent position in y will change, apparent position in x will not change. Next, consider YDSE experiment. What should be the slit separation d in terms of wavelength such that first minima occurs in front of the slit. So this is S1, this is S2, and first minima is here, first minima is in front of the slits. So we will simply say that the part difference S2p minus S1p for first minima, it is half of wavelength lambda by 2. This is given to be 2d, this is given to be d. So S2p is root 2d whole square plus d whole square, which is root 5d. So S2p is root 5d minus S1p is 2d is equal to lambda by 2. So d, if we take common, root 5 minus 2 is equal to lambda by 2. So the slit separation d should be lambda by 2 times root 5 minus 2. Next question, point source is placed in a very small height h above the flat refracting surface. The shape of interference fringes is. So why will interference occur? Because this is a mirror, this is a source. There will be an identical source formed here behind the mirror, which will act as a virtual source. And these two, suppose this is S1 and the virtual source is S2, now they will interfere at different points to give us maxima and minima pattern. So if we look at S1 and S2, they will have some part difference and some interference pattern will be formed on the screen, and this pattern will be circular in nature. Just by looking at the symmetry, it will be circular in nature. But if we have a screen here, it will be just like Young's double slit experiment, and we'll get hyperbolic or straight line fringes depending on the experiment. So here we get circular. Next question, nucleus breaks into two nuclear parts with velocities in the ratio 2:1. What is this ratio of their nuclear size? So whenever something breaks into two parts, the total momentum of the system should remain 0. So the two parts should have the same momentum in opposite directions. So I'll just say m1 v1 should be equal to m2 v2. So v1 by v2 is m2 by m1, and it is given by 2:1. M2, M1 are in same ratio as A2 and A1, which is the mass number. And A2 and A1, we know that A is proportional to R cube. So R2 cube by R1 cube. So from here we get R1 cube by R2 cube. Or simply let's do it like this. R2 cube by R1 cube is 2 by 1. Just by comparing these two. So we get R2 by R1 as 2 to the power 1 by 3 by 1. So R1 by R2 is 1 by 2 to the power 1 by 3. Next question. A nucleus originally at rest emits an alpha particle with speed v. What is the speed? Recoil speed of the daughter nucleus. So again it's the same concept. Whenever something breaks into two parts, momentum of the two parts should remain same. So momentum of the two parts, suppose this is alpha particle, this is the daughter nucleus. What is the mass of the daughter nucleus? It emits alpha particle, so the mass reduces by 4. Initially the mass was 210. It releases alpha particle, the mass reduces by 4, so the mass is 210 minus 4 into some recoil velocity u, which we don't know. This is m into v, and this should be equal to the momentum of the alpha particle. The mass of the alpha particle is 4 into the speed given is v. So we will get 206 u is equal to 4v. So the recoil speed of the daughter nucleus is 4 by 206 into v. Next question. AVS represents acceleration, velocity, displacement of the moving particle. K is some dimensionless constant. A is given by this expression. What is alpha and beta? So A is LT minus 2. We are applying dimensional analysis. A is LT minus 2. K is dimensionless. V is LT minus 1 and it has power alpha. S is simply length. It has power beta. So L has total power alpha plus beta. T has total power minus alpha. Here it is LT minus 2. Comparing the powers, we get alpha plus beta is equal to 1 and minus 2 is equal to minus alpha. Implies that alpha is equal to 2. Put it in above equation, you will get beta is equal to minus 1. Next question. In YDSC, how many maximas can be obtained on the screen on both sides of the central fringe if lambda is 2000 angstrom, distance between the slits is 7000 angstrom. If we carefully see, they are comparable to each other, and if we look carefully, we'll get that distance is actually 3.5 lambda. So if we draw the diagram, we'll get two slits S1 and S2 which are separated by some distance of 3.5 lambda, and we have a screen here. Let's count the number of maximas. So just at the center, the part difference will be 0. Delta x is equal to 0. So we'll get a maxima. If we slightly shift upwards, S2P and S1P have some part difference between them. S2P is longer than S1P, so the part difference will slowly increase, and as we go higher and higher, somewhere the part difference become equal to lambda. And again we get a maxima. As we go higher and higher, somewhere we'll get lambda is equal to this, somewhere we'll get delta x equal to 3 lambda also. But if we go very far away at infinity, the part difference between these two becomes 3.5 lambda. Very far away here, this length minus this length becomes 3.5 lambda, which means at infinity we get a minima, because delta x, maximum value of delta x is 3.5 lambda. So we are getting 3 maximas here apart from the central maxima, and similarly 3 maximas we will get in the lower direction as well. So we are getting 3, 3 plus 1, which are 7 maximas in total. Next, physical quantity Q is related by 4 observables given by this. What is the percentage error in Q? So percentage error in Q, delta Q by Q, is simply given by 2 by 5. We write the power like this, we'll get delta x by x, plus write the power delta z by z. Always write positive power delta y by y, plus 1 by 2 delta t by t. So you will get 2 by 5. Delta x by x is the error in x, which is 2.5%, plus 3 times delta z by z is 3 times 0.5, plus delta y by y is 2%, and it is half into delta t by t, which is 1%. So when we solve it, we'll get 2 into 0.5 plus 3 into 0.5 is 1.5 plus 2 plus 0.5. So you will get 1.5 plus 0.5, which is 2, plus 2, 4, plus 1, 5. Next question. A neutron breaks into proton and an electron. Then the energy released during the process is this much. Find the value of R. So basically, when will the energy be released? Energy is released whenever the mass of the products is less than the mass of reactants, and the difference in the mass goes into energy. So actually they gave approximate masses of proton and neutron. So technically this question will become slightly wrong. So we will just assume, we will just say how much energy is involved in the process. How much is the energy involved in the process? So we will say in any process, how much energy is involved? Delta m into c square. Initially it was only a neutron, then it is a proton and an electron. So the mass of reactant and the product is not same. The difference in the mass here is only here the mass of electron into c square, which is 9 into 10 to the power 16. When we solve it, we'll get 81 into 10 to the power minus 15 joule. Technically, if we take the question at its face value, it should be energy absorbed in the process, if the masses are given like this. Next question. Nth bright fringe of red light coincides with n plus 1th bright fringe of green light. Find the value of n. Suppose they coincide at distance d. So this distance is at n fringes of red, beta of red, and n plus 1 fringes for beta of green. So n into lambda for red, capital D by small d, is equal to n plus 1 lambda for green, capital D by small d. So n into 7500 is equal to n plus 1 into 6000. So you will get n by n plus 1 is equal to 4 by 5, implies that n is equal to 1. Last question. A convex lens of focal length 30 centimeter is placed in contact with a concave lens of focal length 20 centimeter. So let's first calculate the effective focal length. So 1 by f will be simply, we add the powers, f1, 1 by f1 plus 1 by f2. So 1 by focal length of convex lens is positive and of a concave lens is negative. So if we write it like this, we'll get minus 1 by 60. So the focal length comes out to be minus 60 centimeter. Now an object is placed 20 centimeter to the left. So u is equal to minus 20. So if we use lens formula 1 by v minus 1 by u is equal to 1 by f, we will get 1 by v is equal to 1 by u plus 1 by f, which is minus 1 by 20 minus 1 by 60 is equal to minus 4 by 60. Implies that v comes out to be minus 15 centimeter. So distance of the image is 15 centimeter from the lens system. So that's all for this paper. Thank you so much.